Welcome to the series of data structures. In this particular video, we will understand the concept of trees and how it is different from data structures like linked list or any other, and what are the basic concepts and what are the basic terminologies we need to understand before trying to solve the problems. Okay, trees are very similar to linked list, but instead of pointing to one node, it can point to number of nodes. For example, in here we can see that linked list in this node in this linked list is pointing to one node, but at the same time, in case of trees, node A is pointing to B, C, and D. Similar to node B is pointing to E and F, node C is pointing to G, and so on. Before we go forward for the problem solving, we need to understand few concepts of trees. First of all, let's just try to understand what is root. Root is a node which does not have any parent node associated with it. So in this particular case, A is termed as root node. Next, we need to understand what are edges. Edges are links from parent to child. So here, A to B, there is an edge. So this is one edge. A to C, this is an edge. A to D, there is an edge, and so on. Next, we need to understand is what is depth of a node or height of a node, or same way, what is height of a tree. So first of all, we'll see what is depth. Depth of a node is basically calculated. It is the length of the path from the root to the node. So we will see, let us say depth of D. If we want to calculate, then we have to see from root node to D how many levels are there. What is the path? How many edges are there? So there is only one, A to D. So that's why the depth of D is equals to 1. Similarly, if we want to calculate for K, depth of K is from A to C, C to G, G to K. So the depth of K is 3. Next concept is height. Height of a node is calculated as the deepest node from that node in the path. So if you want to calculate the height of D, from D there is only one level deep node is available. So that's why in both directions, like left or right, so that's why D's height is 1. If you want to calculate A's height, then the deepest node are K and J. So the height of A is A to C, C to G, G to K. Height of A is 3. Next, we will try to understand what are skew trees. Let us say in your tree, every node has only one single child, then that tree is called as skew tree. So this can be a skew tree. If every node, every child node is, if you have every left child node in the tree, then that is called left skew tree. Similarly, every child in the tree which has every node has a right child node, then that is called right skew tree. Next, we will try to understand what are binary trees. To fulfill the criteria for binary tree, every node should have either 0, 1, or 2 child nodes. Also, you can say that from the root node, you can try to understand in this way, like it has 2 disjoints subtree, one on the left side and one on the right side. Let's take an example. Let us say on the right side here we can see node 1 has 2 child nodes. Yes, it fulfills the criteria. Node 2 has 1 child node. Yes, it fulfills the criteria of binary tree. Node 3 and 4 has 0 child node. Still it fulfills the criteria. So we can say that this is a valid binary tree. Next, we will try to understand the types of binary tree. There are 3 types of binary tree. One is strict binary tree. One is full binary tree, or full binary tree. And one is complete binary tree. In strict binary tree, every node has exactly 0 children or no children. So this, if you check this particular case, then we can validate that yes, this is a valid strict binary tree. In case of full binary tree, it should have the same property as of strict binary tree, that is, every node should have exactly 0 or 2 children. But at the same time, all the leaf nodes should be at the same level. Okay, I missed one part in the first video. In trees, the structure, it is actually represented in a hierarchical form, and in each levels. For example, node A is at level 0, node B, C, D are at level 1, node E, F, G, H, I are at level 2, and node J and K are at level 3. So they are represented in that particular way. So in case of full binary tree, we are back to the same screen. In case of full binary tree, it should have either 0 or 2 child nodes. At the same time, all the leaf node should be at the same level. Let's just try to see what is complete binary tree. In case of complete binary tree, before we go forward, let's just take a case like, let us say the height of the tree is h. Then we would like to say that in case of complete binary tree, the binary tree will be called complete binary tree when all the leaf nodes are either at h or h minus 1. Also, they should be in a sequence, like here we can say all the nodes are in sequence. In the next video, we will try to understand basic operations and structures of binary tree and trees, and basic operations like inserting, deleting, searching, and traversing the element. If you like this video, then please subscribe to this channel and don't forget to give thumbs up. Please give your valuable feedback so that I can improve my content and help many other developers. Thanks for visiting.